Hello, welcome to Easy Physics. Let's discuss some more questions from June 2018 CSIR-NET Part B portion.
तो इस क्वेश्चन में particle is moving in a circular ring of radius r. Perturbation is given to you and you have to find out the shift in energy of the ground state to first order in A is. आपको first order correction निकालना है to the ground state. Perturbation is given to you. Now you need the wave function of the ground state. What will be the wave function of the ground state? So I have linked one wiki article by which you can find out that the ground state wave function of a particle of mass m is constrained to move in a circular ring is wave function is 1 upon under root 2 pi e to the power plus minus I and phi. N is the n will vary from 0 plus minus 1 plus minus 2 and so on. So from here we can say that ground state wave function of a particle constrained to move in a circular ring is 1 upon under root 2 pi. Now from the how we will calculate the ground state wave function? First order correction in the ground state wave function. So that will be equal to sine perturbation okay. So this will be equal to, so V dash is, so A upon R square is constant. We are taking this out. And so in integral form, we can write this as psi naught star V dash psi naught. So psi naught is a real quantity 1 upon root 2 pi. So it will become square of it. It will become 2 pi integration limit 0 to 2 pi limit of phi limit 0 to 2 pi cos square phi d phi. Now what is cos square phi? So cos square phi is equal to 1 by 2 1 plus cos 2 phi. So we can put all these things in the previous equation. So we will get alpha upon r square into 1 upon 2 pi limit 0 to 2 pi plus cos 2 phi d phi. So this term will become 0 because integration of cos 2 phi is sine 2 phi divided by 2, and sine, if put limit, then sine 2 pi, 4 pi is also 0 and sine 0 is also 0. And the integration of 1 is phi. So if you put limit, so it will become 2 pi. 2 pi will cancel out and you will get alpha upon r square as answer. Alpha upon 1 by 2 is also here. So the answer is alpha upon 2 r square. In this question, it is asked that the coefficient of volume expansion and the isothermal compressibility K of a solid is, both are intensive variables. Alpha is an intensive and K is an extensive variable. Alpha is an extensive and K is an intensive variable, or alpha and K both are extensive variable. So for this, we should know that what is isothermal compressibility and what is coefficient of volume expansion. So if we talk about the coefficient of volume expansion, which is denoted by alpha, so alpha is equal to 1 upon V del V over del T. Means the fractional change in volume by increasing the temperature. And isothermal compressibility. Isothermal compressibility is represented by symbol K, and it is 1 upon V del V over del P at constant T. So as the name suggests, isothermal means at constant temperature, and compressibility means change in volume on increasing pressure. So isothermal compressibility is the fractional change in volume on changing pressure. So this is the definition of alpha and K, and alpha and K both are the intensive variables. Intensive means, if we change the quantity of a substance, then the intensive variables remains unchanged. The or you can say the value of intensive variable remains unchanged. So in this question, the answer is first, that alpha and K both are the intensive variables. In this question, a particle is confined in an infinite potential box, and you have to find out the number of eigenstates of Hamiltonian with energy this. So energy is given to you. Energy is given to you. En is equal to n square pi square cross square upon 2ma square. But this is the case for three-dimensional infinite potential box. So we will write it as nx square, ny square, nz square, pi square cross square upon 2m square. And this is given to you 9h cross square pi square upon 2ma square. Now we have to find the value of nx, ny, nz, for which the sum of nx square, ny square, nz square will be 9. And how many such values are possible? So if you put, so for infinite potential box, the n is the ground state is starts from 1. So ground state will be nx is equal to 1, and y is equal to 1, and z is equal to 1, and the energy will be 3 pi square h cross square upon 2ma square. Now the next energy state will be 2 1 1, 2 1 1, and the value will be, the energy will be 4 plus 1 5 plus 1 6. So 6 pi square h cross square upon 2ma square. And the second excited state 2 2 1. So 4 plus 4 plus 1 will be 9. 9 pi square h cross square upon 2m square. And we can write this 2 2 1 as 2 2 1 2 1 2 and 1 2, means nx, ny, and z. Sometimes in this first, nx will be 2, ny will be 2, and nz will be 1. And this in second, nx will be 2, and ny will be 1, and nz will be 2. Similarly, in the third one. So these are the three possible values for which the energy will be 9 pi square h cross square upon 2m square. Is any other value possible? No, because if you find the third solid state, then that can be 311, because then the energy will be 9 plus 1 plus 1. So 11. And one more is 2, 2, 2. So for 2, 2, 2, it will be 4 plus 4 plus 4, 12. So, so three eigenstates are possible for this one, for this energy. So the option 3 will be correct. If you want me to discuss any topic related to CSIR-NET, GATE and any other national level exams related to physics, please comment in the comment section. मुझे खुशी होगी आप लोगों से डिस्कस करने में फिजिक्स का कोई भी टॉपिक.
If you want more videos or more solutions like this, for that you just need to do one thing. Press the thumb icon, subscribe and hit the bell icon, and please share with your friends. Thank you.